Hello and welcome to Investigative Maths. This is the first video in this series about confidence intervals. We'll cover just like an introduction to confidence intervals. We'll talk about alpha level. We'll talk about the difference between sample distributions, sampling distributions, lots of prerequisite knowledge that you're going to need before we can actually get into the equations for confidence intervals. So if you're already really comfortable with that, feel free to skip to the next video. If you're thinking maybe I don't want to keep going, I highly suggest that you watch this video because there is going to be a lot of background knowledge that I'm going to assume in future videos. So let's just get the ball rolling. So the first piece of prerequisite knowledge that you're going to need that pretty much lends itself to the entire field of confidence intervals is the difference between a sample distribution, and a sampling distribution. Okay, so this is the difference. So you're probably more familiar with sample distributions. This is more of like your basic statistics. This is like you have a big population, right? For both of these, let's just use the population of people in the United States. So let's just use like 330 million. I think that's pretty close to the population. And a sample distribution would be like I sample 1,000,000 of these people, and I want to find like the average height maybe. And I'm looking for the average height. And let's say that average height is, I don't know, 66 inches. Just picked a number. That's 5'6". That should be pretty close to the average height. But the point is that I'm just taking one sample. I'm taking this one sample of 1,000,000 people, which honestly, realistically, you probably wouldn't sample that many people, but the idea is that you have this big population, and I'm taking one sample, and this is the mean of my sample. This is an X with a bar over it, by the way. That's a symbol for a sample mean. Okay, the difference between that and a sampling distribution is that instead of taking one sample, I'm taking a bunch of samples. Say I'm taking 20 samples. Okay, and each one of these samples will have their own mean. You have your mean 1, mean 2, mean 3, all the way to your 20th mean, right? And you treat these means that you calculate here as if they were the people sampled in the sample distribution, right? So whenever you're creating your sampling distribution, right, if it's going to look something like a bell curve, right, the mean of this would be the mean of all 20 of these means, right? Some of your sample means are going to be under the average, some of your sample means will be over the average. But the point is that for a sample distribution, we have one sample. For a sampling distribution, you have a bunch of samples, and we're trying to find the distribution of all of these different samples. So that's the big difference. So why are we even talking about this? The reason that I brought this up is because this is pretty much your entire introduction to the idea of confidence intervals. What confidence intervals try to answer is, given a certain sample distribution, right? Let's say I had this 1,000,000-person sample, and I find that the mean of those 1,000,000 people is 66 inches, right? Given that information, and you would also need some other information, but I'll talk about that in the next video. Given this information, what predictions can I make about the sampling distribution? So here's an example. I have 330 million people, and I took that their mean is 66 inches. So maybe the actual mean, okay, maybe the actual mean, I'm really bad at drawing these bell curves, but it'll get better throughout the video. Let's say the actual mean, which is noted with this mu, is maybe it's actually 67 inches, okay? Maybe it's actually 67 inches. But this sample, it gets us pretty close, right? it gets us to like 66, right? So what confidence intervals allow us to do is they give us a range that, given this sample distribution, given this sample mean, right, we can make predictions about what this actual mean is going to be. So here's an example, or here's maybe a development is a better word. So you may have heard, you may have heard in the context of confidence intervals, like having different degrees of confidence. So there's like 95% confidence, 90% confidence, 99% confidence. Those are probably the three most common. And so whenever you're creating your range, right, it's an interval, it's a confidence interval. The center will always be whatever you get for your sample mean, right? That's your X bar, that's your mean. Your confidence interval will be some amount below that and some amount above that. So let's say that this is like from 60 to 72, right? So I subtracted 6 and I added 6. So this is my interval. And I create this interval to try to see if I can capture what my actual mean is. Okay, so in this case, if the actual mean is 67, I didn't actually Google that. I kind of just took a guess. Someone can comment what the actual mean is. So I create this interval to try to capture this right here. So you might notice that this interval is 12 wide. It's 12 wide, right? I go 6 down and I go 6 up. And the reason I bring that up is because that brings us to the topic of confidence level. So let's say that I made this interval super, super wide. Let's say, you know, that I made this interval like 132 wide, right? 66 is still in the middle here, right? But now I have this huge interval, right, from 0 to 132. And I'm trying to guess if I'm trying to make sure that my mean is inside of this interval. Well, this is a pretty huge interval, right? Like, we're pretty sure that the average person in the US isn't 11 feet tall, right? So this will have a very, very high level of confidence. Very, very, very high level of confidence. And this 60 to 72, this range of 6, that's still a pretty high level of confidence, but it's definitely lower than this one, right? So, like, there's a chance that when I sample this million people, again, it's pretty slim, but there's a chance that when I sample this million people, I got unlucky. And let's say that I accidentally sampled people that were taller on average, right? If you're doing random sampling, there's a chance that that can happen, right? So let's say I sampled a bunch of people, and by some dumb luck, right, I accidentally got that my sample mean was 73. Or actually, I got that my sample mean was 74. This better fits the example, right? Now, if I make an interval that's 12 wide here, I would subtract 6, get 68, add 6, get 80, right? And if I'm looking at this, I'm looking at this right here, well, my actual population mean is 67 inches. But this interval over here that I calculated, it doesn't include that 67. Well, why is that? Well, I have the same degree of confidence as I do here, right? I have the same width of my interval, but it's just because I had this fluke of a sample that happened to have a really high mean. Maybe you had some sort of sampling bias where you only sampled NBA players, or there's not a million NBA players, but you get the idea. But just you can have this fluke where your sample mean is way higher than your actual mean, and this is and you would get this interval that wouldn't contain your mean. Okay, so where does this bring us to? Yes, so back to confidence level. That's what people mean when they say 90% confidence, 95% confidence, 99% confidence, right? What this means is that given a sample mean, right, whether it be 68 or 74, right? If I'm 90% confident, that means my interval is wide enough that depending on my sample mean, I can be 90% sure that my mean is inside of that. So let's say, I'm going to erase some of this real quick. Let's say that this is my true distribution, right? This is my mean is 67, right? And I get a bunch of sample means. So say I get one sample mean over here, one over here, one over here, right? They should be pretty close to the actual mean, as long as I'm not having a biased sample. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so these are my 10 sample means. Remember, a sampling distribution is taking a bunch of samples with their sample means, right? So let's say I create my intervals large enough that I have a 90% confidence. So this is a little bit more of a visual way of showing that. Okay, for each of these means, I'm going to draw like a rough confidence interval that would show 90% confidence, right? And remember, all of these means are possible, right? All of these means are possible because they're samples. They're not from the population. So there's one, and you see for these first three, they all contain this value of 67, right? They all contain this value of 67, right? Some of them are on the low end, some of them are on the high end. And then we get to this point right here. And we see this point is actually so far off that this point is actually so far off that our confidence interval doesn't include the mean. So let me go ahead and do the rest of these. I'm trying to keep these roughly the same size, but it's kind of hard. So you see, all of these means, whenever you give them a certain width to have 90% confidence, right? 90% of them will contain the sample mean. Okay? Right? We had 10, and 9 out of the 10 contained the sample mean. So this is one that doesn't. So that's what they mean to have 90% confidence, right? If I were to have 95% confidence, maybe that would widen this interval enough. Maybe that would widen this interval enough so that it would contain the mean, right? And now maybe only 1 out of 20 would be outside of that range. And then if I had 99% confidence, only 1 out of 100 would be outside of that range. So this brings us to another definition called the alpha level. And the alpha level and the significance level are very, very, very similar. Pretty much, the alpha level tells you the percent chance, or tells you the chance of having one of these outliers, one of these intervals that does not contain the mean. So you'll see the relationship pretty quickly. Like a 90% confidence, right? If 90 of the intervals contain the mean, then how many of them don't contain the mean? Well, that's an alpha of 0.10. And then for 95% confidence, your alpha will be 0.05. And for 99% confidence, you'll have an alpha value of 0.01. So this is how it's usually written. It can be written either way. You'll see on math tests that it'll either say they want this at 95% confidence, or they will say we want it at an alpha level of 0.05. You usually don't say alpha level of 5%. Usually you say it as the decimal.